warm greetings to all. Myself R.Poornima and my friend J.Abinayasri from the Department of Computer Science, Kaveri College for Women, Autonomous, Trichy 18 are going to present an e-content on OSI layer model and TCP IP model. First, we are going to see about the OSI model. The OSI model is the Open System Interconnection Reference Model is the result of the effort. The OSI model describes how data flows from one computer through a network to another computer. The OSI model is not a protocol. It is a model for understanding and designing a network architecture that is flexible and robust. The OSI model consists of 7 separate but related layers, each of which defines a part of the process of moving information across a network. In the OSI model, the physical layer consists of media, signal, and binary transmission. The data unit consists of bits, and the data link layer, it consists of MAC and LLC physical addressing. The data units are of frames, and then the network layer consists of path determination and IP logical addressing. The data unit consists of packets, and then transport layer. It has the end-to-end connection reliability. The data units are the segments, and the session layer has the inter-host communication. Next, the presentation layer consists of data representation and encryption. The application layer works on the network process to application. First of all, we are going to see about the physical layer. Physical layer is responsible for transmitting raw bit stream over the physical cable. It is responsible for the actual physical connection between the device. The physical layer is responsible for movements of individual bits from one node to next. Here is the diagrammatic representation of the physical layer. The physical layer, the data transmits through the transmission medium. Then the functions of the physical layer are data encoding, transmission technique, physical medium transmission, physical topology, switching. Physical layer, it have the physical structure that are coax, fiber, wireless, hubs, repeaters. And then we move on to the data link layer. Data link layer is responsible for controlling the error between adjacent nodes and transfer the frames to other computer via physical layer. The data link layer is responsible for moving frames from one node to the next. The diagrammatic representation of the data link layer and how it will work from the network layer. And the functions of the data link layer: link establishment and termination, frame traffic control, frame acknowledgement, flow control, error control, physical addressing. The data link layer have the frames of Ethernet, PPP, switch, bridge, etc. And the next layer of the OSI model is the network layer. This is a layer is responsible for translating the logical network address and names into their physical address. It's responsible for the source to destination delivery of packets across multiple networks. It is responsible for the source to destination process delivery of entire message. Here is the representation of a network layer, how the data are transmitted through the transport layer. The functions of the network layer are subnet traffic control, logical physical address mapping, frame fragmentation, routing. In the network layer, the data units are of packets. The packets are IP, ICMP, IPsec, IGMP. Next, we move on to the transport layer. Transport layer is responsible for the source to destination process delivery of entire message. This layer is responsible for end-to-end deliveries of message between the network host. The transport layer provides two types of services: connection-oriented transmission and connection-less transmission. Here is the representation of the transport layer, how it will works in the OSI layers. Functions of the transport layer: message segmentation, message acknowledgement, session multiplexing, service point addressing, error control, and then flow control. The transport layer have the end-to-end connections. It will have the TCP and UDP. And then we move on to the session layer. It is responsible for beginning, maintaining, and ending the communication between two devices, which is called session. This layer is responsible for establishing the process-to-process communication between the host in the network. Here is the representation of session layer, how it will works in the model. And then functions of the session layer are session establishment, maintenance and termination, session support, dialogue control, synchronization. The session layer have the establishment, maintenance and ending a session is most important. Sends SYN packet, establish request, receives ACK and SYN established. To end, sender sends ACK. Sync and send to port are APIs, sockets, WinSock. And then we move on to the presentation layer. This layer is concerned with the syntax and semantics of the information exchanged between two systems. The presentation layer is responsible for protocol, conversation, date encryption, decryption, expanding graphics command, and the date compression. The functions of the presentation layer are character code translation, data conversion, data compression, data translation, data encryption. Here is the representation of presentation layer, how the data are encoded, encrypted and compressed data are transmitted through the application layer. In the presentation layer, the syntax layer are SSL, SSH, IMAP, FTP, MPEG, JPEG. And finally, we move on to the application layer. The application layer provides user interface and support for service like email and file transfer. The application layer provided different services to the application. Here is the application layer representation of how the user will works on the application layer. And then functions of the application layer: remote file access, electronic messaging, directory services, network management, network virtual terminal, file transfer and mail service. The application layers have the end user layer are HTTP, FTP, IRC, SSH and DNS. And next we move on to the TCP/IP model. TCP/IP forms the base of present-day Internet. TCP and IP are two protocols of this model. This model was initially used by R.Poornima. In the TCP/IP protocol, suite was defined as having four layers: host to network, internet, transport and application. TCP/IP are two protocols of this model. TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. There are four layers in TCP/IP model. Next, we are going to see about TCP/IP model. In both the OSI and TCP/IP protocol, they provide the guidelines to perform communications. In the OSI model, we will already seen the 7 layers, whereas in the TCP/IP model, there were only 5 layers. In TCP/IP model, first we going to see about application layer. The application layer in TCP/IP groups the function of OSI application, presentation layer and session layer. It will represent data to the user plus encoding and dialogue control. The layer is the combination of application, presentation and session layer of the OSI model. The layer provides various services to different user application. And then functions of the application layer. It refers to standard network services and also define compatible representation of all data. Telnet terminal network used for remote login. FTP file transfer protocols for transfer of file from one system to another. And then transport layer. In TCP/IP architecture, there are two transport layer protocols. The Transmission Control Protocol (TCP) guarantees information transmission. Transport layer is similar in functionally to transport layer of OSI model. Transport layer of TCP/IP model also provides connection-oriented and also connection-less services. For connection-oriented TCP Transmission Control Protocol and for connection-less UDP User Datagram Protocols. TCP Transport Layer used TCP for reliable connection-oriented services. The various functions of TCP are error control, flow control, and sequencing. UDP Transport Layer used this protocol for unreliable connectionless service. No assurance that packet reached, no sequencing and no error checking. Useful in real-time data transfer and quick transfer of large data. Then move on to the Internet layer. The Internet Protocol IP is the primary protocol in the TCP/IP network layer. The functions of the Internet layer manages addressing of packets and delivery of packet between networks. Fragment packets so that they can be default with by lower level layer. And then network layer. In the TCP/IP architecture, the data link layer and the physical layer are normally grouped together to become the network access layer. Functions of the network layer. It delivers data via physical link and provides error detection and packet framing. And finally, we are going to see about the OSI model versus TCP/IP model. The OSI model consists of 7 architectural layers, whereas the TCP/IP only has 4 layers. The OSI is a reference model and TCP/IP is an implementation of OSI model. The OSI model, however, is a generic protocol independent standard. The OSI model has 7 layers. The TCP/IP has 4 layers. OSI model provides clearly distinction between services, interfaces and protocols. TCP/IP does not clearly distinguish between services, interfaces and protocols. In OSI model, transport layer is connection oriented. In TCP/IP, transport layer is both connection oriented and connectionless. Hope that all you clearly understand about what is OSI layer model and TCP/IP model. Thank you. Have a good day.